Okay, here's a paradox for you. What if the very box that's meant to protect a luxury product is also the thing that puts it at the greatest risk? Today, we're going to step into the role of a technical director and pitch a solution to that exact problem. It's a system designed to bring total, absolute transparency to a supply chain that has frankly been operating in the dark for way too long.
This sentence right here, this is it. This is the entire problem in a nutshell. You've got these incredible, cutting-edge products, but the system we use to move them around the globe is, well, it's stuck in the past. So let's really dig into what that means for a very specific and very valuable industry.
So the whole issue really starts with this fundamental conflict, something we call the premium paradox. It's this constant battle between what the market is screaming for and what our current logistics can actually, deliver safely.
On one side, you have the shipper's dream. These tight, durable flower buds. They're resilient, they're practically bulletproof during transit. Easy. But on the other side, you've got what the customer actually wants to buy and what they'll pay a premium for. These spectacular, fully opened blooms, right at their absolute peak. The catch? They are unbelievably fragile. Their perfect lifespan is measured in hours, not days.
And you know what makes this risk so much worse? It's a massive technical problem that's sitting right at the heart of modern logistics. It's a total information blackout. The source material calls it the connectivity chasm, and honestly, that's the perfect name for it.
The entire issue boils down to some pretty basic physics. You see, every single standard metal shipping container, the workhorse of global trade, is by its very nature a Faraday cage. It's a metal box that is literally designed to block the exact signals, GPS, cellular, that our entire modern logistics network relies on to function.
And this is the result. The second that container door closes, that precious cargo inside enters a digital black hole. No data gets in, no data gets out. No GPS, no cell signal, nothing. From that moment on, everyone responsible for that shipment is flying completely blind. So how in the world do you solve an information problem that is literally built into the steel walls of global trade? Well, you don't fight the physics. You use the physics. You turn the problem itself, that metal box, into the solution. The way we do it is with a technology called Near Vertical Incidence Skywave, or NVIS. Now, instead of a signal that needs a clear line of sight, this system sends a high-frequency radio wave straight up into the sky. The Earth's ionosphere acts like a giant mirror, bouncing that signal back down and creating this massive umbrella of coverage that isn't blocked by things like mountains or buildings. And this is where the real magic happens. When that NVIS signal hits the steel shipping container, it actually induces an electrical current in the metal. The entire container becomes a giant antenna, rebroadcasting the signal to the tiny little sensors deep inside the cargo. The cage becomes the conductor. But look, just getting the data out, that's only half the battle. Because raw data without intelligence is really just noise. You need an intelligence layer on top of it to make that data actionable, and you need it to act instantly, without waiting for a person to check an email. So we solve this with a team of specialized AI agents. Seriously, think of them as your own digital workforce. You've got Maestro, who's the boss, the strategist. Then there's Oracle, the analyst, who's constantly scanning the data, predicting problems before they even happen. And finally, there's Aegis, the front desk, the one who actually communicates with the real world, texting a driver or alerting a warehouse. These agents are always working together in what we call a digital huddle. So imagine a sensor inside reports a temperature spike. Instantly, Oracle flags it as a risk. Maestro decides the best course of action is to reroute the truck to a nearby cooling facility. And Aegis autonomously texts the driver with a new route and notifies the facility to get ready for their arrival. All this happens in seconds, before a human ever even knows there was a problem.
So, let's get to the crucial point, right? What does this amazing combination of physics and AI actually deliver? What is the real-world, bottom-line outcome of having this kind of total visibility? Well, for starters, it has a direct, measurable impact on the bottom line. Because you can intervene in real time, you prevent product from being lost. The source material projects a 10 to 15% reduction in annual spoilage. I mean, in a high-value industry like this, that is a huge number.
And this slide just illustrates the difference perfectly. On the left, that's the standard outcome. It's a gamble. Maybe the flowers make it, maybe they don't. But on the right, that's the glass pipeline outcome. We're moving from a gamble to a guarantee. We're delivering a perfect, premium product with a completely verifiable digital record of its entire journey.
So the return on investment here is crystal clear. And it really breaks down into 3 key areas. First, like we just saw, there's that direct reduction in waste. Second, you get this massive boost in efficiency because the AI is automating all the chaos of scheduling and tracking. And third, and this might be the most important, you build an unbeatable brand. You're not just selling flowers anymore, you're selling proven provenance, a verifiable digital guarantee of quality.
So, the thing is, this isn't just a cool concept on a slide. Let's talk about how we make this a practical reality. What's the very next step? The next step isn't to sign a big contract. No, it's a proof of concept. We want you to see this technology in action on one of your own critical routes, let's say from Quito to Los Angeles. We'll set up a workshop, let you validate the physics, and show you the data with your own eyes.
And we'll just end with this thought. We've shown how this technology can create unprecedented real-time transparency for one of the most fragile, valuable products on the planet. We've solved the Faraday cage problem. So, the real question is, if we can do all of this for a flower, what other critical supply chains are still out there operating completely in the dark?